This is a short video which is going to provide an overview of section 7.5. So we've been looking at sampling distributions for a sample mean, x bar. Now we're going to look at sampling distributions for a sample proportion. So the underlying distribution is the binomial distribution. Remember the binomial distribution where an example would be failures and successes, where P is the chance of success and Q is the chance of failure, and together those are going to add up to 1. And so we talked about this, I believe it was in chapter 5. So we're going to look at that. We're going to look at distributions of a binomial in this section. So we're going to have the number of successes and the number of trials. Successes are going to be X. The number of trials are going to be N. And we have to check that N times P is greater than or equal to 5 and N times Q is greater than or equal to 5. So what we're going to do, the sampling distribution of the proportion is going to describe the pattern that proportions follow when randomly drawn from a population. So we're still talking about samples and population, but this time it's not a mean, we're talking about sample proportions. The standard deviation for this distribution is still going to be the sigma, but you're going to have a p because that is the standard error of the proportion. So here are the two main formulas for this section. To get your sample proportion, you're going to take your number of successes and divide by your total sample size. Once you get your proportion, you can use this formula to find the standard deviation for the proportion, or the standard error for the proportion. And then you're going to get a z-score, but this time it's going to be a z-score for a proportion. Now once you get your z-score, you're going to work it similar to what we have done in the past. So that is just a quick overview. I was going to see if there was anything else that, if NP is greater than or equal to 5 and NQ is greater than or equal to 5, the normal distribution can be used to approximate the binomial. So you have to check that rule first, and then you're going to do your z-scores, and here are the steps. But notice that this part over here, you're going to work it the same way. The only difference is at first you're using proportions and you're making a claim about a proportion. And then you're going to have that same finite population correction factor. Remember, if the sample divided by the population is greater than 5%, then you have to add this part to your formula. And that is pretty much an overview of what I wanted to talk about, and that's pretty much the rest of the chapter. So we're ready to get started working some problems.